What's holding you back from starting or growing your business into what it can be? Well, if you're watching this, it's not a lack of information. What you're about to see is all you need to get motivated to start making waves. Do It for a Living details the journey of today's true players in their own words. Find out how they broke out so you can too. The time is now. The time is always now. Hey everyone, I'm Kevin with the Do It for a Living podcast. In this episode today, we've got our co-host who is now going to be sitting on the hot seat today, Richard. Richard, how you doing today?
Doing well. How are you doing?
I'm doing good. So me and Richard talk a lot, and we just spent the entire PRI show driving up to from Dallas up to Indianapolis. And, it's a 16-hour car drive for us. And we got to talk a lot about what to do. And one of the things we covered was manufacturing. So in our previous interview with Alejandro and Pablo, they even talked about it where they were trying to build the bumpers and they struggled to understand their actual cost of it. And they understood that, there's materials and there's nuts and bolts and hardware and there's welding and all this sort of stuff. So there's a lot that goes into manufacturing stuff. But I think it's pretty rare to see shops that truly understand manufacturing. And I myself don't know hardly any of it. But Richard, you are an expert.
I wouldn't say expert, but yes.
So Richard works for Peterbilt full-time. You're a controls engineer, and you work on the assembly line of the tractors. I guess they're called tractors?
Trucks.
Right? Trucks?
Yeah,
okay.
Or tractors.
So you are in-depth into all the lingo that manufacturing of products goes and all the processes to make stuff like efficient, profitable, clean, all these sort of different things that are required to make a good product affordable, I guess is what we're looking for.
Mm-hmm.
And so we can apply a lot of these processes to what shops do. So the manufacturing that we do as a small shop, or even some of the bigger shops that get into I guess more mass production rather than us, where we're doing onesie twosie custom stuff. But even just working on cars is really largely just manufacturing on a one at a time scale. But engine building can be repeatable. And so there's processes we can follow to do that stuff. So why don't you get us started? So the first one that we have on our board here is 5S. So it's a thing that a lot of bigger companies use, and they have people that are actively involved in that. And then they apply these theories and processes to the assembly line. So go ahead and tell us what 5S is, and then just give us examples of how we could apply that into a shop.
Well, 5S is sort, set in order, shine, standardize, sustain. That's quite literally the definition of it. So,
which nobody can remember.
Nobody can remember, which is why I had to look at the paper to see what it was. So, we just talk about 5S as a whole and as a philosophy, and that's about as far as we get as far as the definition of it. But the value of the 5S is to lay your workstations out, to lay your assembly areas, your manufacturing benches or whatever you've got in a manner that makes sense. So you typically don't want waste, which is the biggest thing. You don't want waste and that could be many things. So you don't want waste with wasted movements or wasted processes, wasted square footage or square inches, depending on how big your layout is. And you don't want wasted time, which is what all that kind of boils into. So as you start organizing your work area, as you start looking at your workspaces, you really start to pay attention about how to organize these things and to make them make a lot more sense for you. A lot of the things that a large manufacturer will do is they'll start with the little things, like they only want the tools needed for that one particular job. Say I'm installing engines, or I'm installing LSs, or I'm installing coilovers, and that's all that I do all day. Well, you don't need a whole bunch of other tools or wrenches or pipe wrenches or hammers or things that you don't always use for that particular assembly. And so it's about getting rid of the waste and trying to be more efficient.
So an example, this would be we work on Evos, and they're all metric. Basically, everything is always metric. Mm-hmm. So we literally don't have any standard wrenches at all, except for 7/16, which is an 11 millimeter, and 3/4, which is 19. That's really,
right.
That's it.
That's
right?
it.
So that's an example of a process where you can kind of eliminate waste. And it's not that the tools themselves are waste. You're saying that the waste is going to a huge, gigantic toolbox and looking for, 3 different drawers to find your one, 19 millimeter wrench. Whereas if you have a single roll cab, a small box, and you only have metric tools in it for the vehicles you're working on, it's faster, is what you're implying, right?
Yes, exactly. So you don't have to fumble around trying to find your tooling. You don't have to have a bunch of other drawers in your box that have a bunch of other stuff. Like, for instance, in my own personal roll cab here, I get rid of all the parts out of my roll cab. I only have the metric tools that I need. I've got the screwdrivers that I need, a couple of hammers, whatever. But I had things like extra fuel injectors and brackets and a little thing that had a whole bunch of bolts and random nuts and little fittings and all these other things. And it's like, that's not the place for that. When you're trying to organize your workspace, you have all this extra junk that's just in your way.
Right.
And then you're not organized, because it's like you reach over to grab your 10 millimeter, and then it's like there's 50 other things in the way that you can't get to, or you set it down and now it's lost in a whole sea of bolts that are on your box.
Yeah.
So getting rid of all the extra stuff is really where the organization starts. That's like step one on your 5S journey.
Yeah. And we also do what we instituted this years and years and years ago was the bolt bins. So what a lot of like do-it-yourselfers do is when they're taking a car apart, they put them in little plastic bags and write on it what it is, which is good. That's a good start. But the problem is you have a lot of plastic bags and sometimes they don't label them correctly. But we just went and bought like 24 of those Stanley bins with all the little individual compartments. And
Looks like tackle boxes or
they
something
look like
for fishing.
tackle boxes,
Exactly.
Yeah. And so we just write on the top of each one of them what stuff goes in there. And now over the years, I guess we've gotten lazy or better at what we do, but I don't use the labels anymore. I just dump the bolts for a specific
it's a
part
mental
in a bin.
label.
A mental label, right? But I know I've done so many of them now. When you're taking apart an Evo 8 or Evo 10, I know exactly what bolts they are just by how many of them there are, right? And kind of the general the shape. But if you're doing other types of cars, now this thing saves a lot of time because you don't have to like guess. You could put them in the water pump bin, you put them in the timing pump bin, you put them in the cam cap bolt bin, and you can kind of like know which ones are which without having to fumble through a bunch of Ziploc bags in a box, right? So that's kind of the idea there, right?
And then that bin stays with that customer's car, to where you're not mixing and matching different customer cars. You may have 6 Evo 8s at all the different stages, and well, that's Bob's bin and that's Joey's bin, and then I know exactly whose bin it is, and you don't have to feel like you're robbing parts all the time or trying to figure out whose bin is whose, because every car has their own bin.
Right.
So it's like kind of a twofold thing. You organize the bin itself, and then the bins become the organization.
Right. And this also kind of falls into the cleanliness part of this is if you put stuff away in these bins, when you're done working on the car and you're waiting for the engine to come back from the machine shop, you just shut the bin, you put it in the bolt or the bucket of all the other parts and put it with the car or someplace that you store parts, and it's not in your way constantly, right?
Mm-hmm.
Yeah.
Exactly.
Okay. And number 5, which is sustain, we do a lot of backsliding. So we definitely do a good job of organizing things. And then when you get in a rush, like you're 2 weeks straight of just hammering on cars really quickly, and then the shop gets really messy and dirty because I'm not putting the parts away. I'm not taking the cars apart and putting them into the racks where they should be. And so that's clearly the hardest part for at least me, and I guess us in general, because you're here only on the nights. So you get to come in and clean up after my mess or work around my mess, right?
Or if somebody's coming in behind you, like we have our contractor or one of the other guys come in and they help, and it's like, well, whose bin is who? And I don't know what happened, and where's this stuff? And now it becomes this thing to where someone can take it apart and then someone else can put it together, because they understand that this is so-and-so's parts. Here's the bin, here's the order. And it's really easy to put it back together.
That's true. And that has been a very helpful, because we can have George or Lance or Jackson. We can take it apart and they have all the stuff right there and they can put it back together. So that is very helpful. And then as far as like manufacturing goes, we kind of talked about this as a shop, like working on cars, but like the manufacturing side of things is equally as important. And also, at least for us, I would say we do a better job of organizing our manufacturing, and we keep improving this because we're just super small. Like we're just making onesie twosie stuff, or I guess really we make 10 surge tanks at a time, or 10 or 15 flex fuel kits at a time, or we're making really small runs at it, but laying it out in a way that's easy to, like, here's the tools that I need to put the flex fuel kits together. Here's all the parts. So we have the Fastenal bins with all the individual pins, so the wiring pins, and then we've got all the AN fittings that we use to assemble the kit. We got those in bins sorted out exactly how we're going to assemble it. So that's all kind of falls into the 5S, like kind of organizing your station. And you kind of like started all this process when you kind of designed our flex fuel kit. So
Mhm.
how did you kind of like decide how to like what parts we want to use, and then what's the process for putting that together and making your station ready to go?
So I guess you start with your design or how what you're going to build. And so you start out with trying to, it kind of turns into one of our later conversations about how we design stuff, but from an engineering perspective. But whenever you are starting to design your product, you always try to minimize the number of components. That lowers your assembly time, it lowers your part cost, all of that stuff. So once you kind of get the design set, in those bins you're talking about, it was really just the order of operations.
Hmm.
So you build the wiring component first, and then you build the hose or the plumbing part of it second. And so you just lay it out in your bin based on the order of operations. So similar with your tools, you get out your cutter and you get out your two wrenches or your vice tool to hold the end while you're crimping it down. You start out with those kind of things laid out in order, and we'll get into some of the ways that you organize that in a minute. But um, the key of that is just keeping it in organized in order.
Okay.
And so whenever you are keeping that in order, and whenever your parts get low, you automatically know exactly what your order points are. You start talking about um, how you need to keep everything stocked. And if certain things get used faster than others because the way that you're ordering stuff, it all kind of falls into that same organization part, which is your set in order as part of your 5S. So you're trying to go in order as part of your order of operations.
Okay. And you touched on this. This is I think something Alejandro maybe could have used a lot. Was you said to minimize the amount of stuff you need to build it. So that is a big part of the design thing. And then additionally, this is something we were guilty of with our oil filter housings, or at least Lance was. You build the oil filter housings and we have 7 different colors of it. And then we have 2 different springs. And then we have some of them with a gasket and without a gasket. So we had like 150 different variations of this single part that we make. And it becomes super complicated to fulfill orders because every one of them is unique.
Mhm.
And I actually told Lance, I'm like, we're not going to do this many colors, and we're only going to do one spring offering. If people want the other one, they can order it on their own, right? And
Mhm.
and so that brought the selection down to just a handful of colors, and that's it. And now it's really easy to fulfill because I have all of them pre-boxed.
Mhm.
So when I get an order, I literally just go and pull the box off the shelf, put it in another box, put some packaging material in there, and ship it, right? So the order fulfillment is a lot easier because I don't have to deal with every single one of them being unique and having to go through and individually pick what spring it's going to use, and then what color it is, and then if it's going to include the gaskets or not. And it's so that just kind of speeds stuff up and it makes it a lot easier to handle, right? So
And that really, and then what you're talking about, you touched on there with the variation, that kills your manufacturing. So, or your manufacturing efficiency specifically. So, if you have a lot of variation and it may be overcomplicated variation, a lot of times if you don't charge for that or you don't properly assign your labor for that, then you're not going to make any money on it because all you do is just spend all this time trying to manage your variation set.
yep.
And like you said, I had to pull these bolts and this gasket and this spring, and then either you assemble it or you have to account for every single component in each box individually before you pack it, you package it and do all the shipping components there. So it becomes a lot to try to deal with this variation if you remove the variation from the beginning, like you get this or that, and that's all you get, then you're already way ahead in the efficiency number, and so then your labor or the pieces that you're putting into it for your cost or for your profit becomes a lot more profitable
Yeah.
because you're not having to spend time on variation that may or may not be needed.
Right. And I think a lot of it makes it unnecessarily complex for everybody, both for the
Right.
customer and for the shop fulfilling the order, right?
Hmm.
Okay, so this kind of gets into something that is relevant, and you've always done this for us, is the bill of materials, essentially the components you need to build out the product you're manufacturing, right? So
Hmm.
explain what that is and how important that is in a manufacturing setting.
Yeah, so that becomes really important, and it needs to be a documented bill of materials because it can't be on a piece of paper written with Sharpie, and then your piece of paper goes, or you get some oil on it, and what part number was that? I have no idea. So yes, that becomes very important. So I think it started with what the surge tanks that we did.
Yep.
We started building those out. So we used to build a surge tank way back in the day, and we had one dude making tanks and another dude anodizing
Anodizing.
them, and we had someone else building hoses, and it was kind of all over the place. And we thought we were making profit, and we really, in the end, weren't,
Right.
because we were not categorizing and we're not ordering the parts like we should.
And then at the end of the day, we were just kind of making up a price at the end, like $900 sounds okay,
Sounds
right?
good. It's like building a roll cage. That sounds right.
Yeah.
But yes, so on the second iteration that we did, not only did we make it more modular and make the design a little more refined, we went into Excel or Google Sheets,
Yep.
whatever you have available, and then we documented every single component. We documented the quantity, documented the costs, and then we put in an actual margin, so we knew exactly how much money we're going to make. And then we took a guess on how long it would take to assemble this, so we put in a labor factor in that as well.
Yeah.
And then we came up with, we had what, 2 or 3 options, like a 1 pump or a 2 pump,
Right.
and then a couple other little options in there. So once again, we reduced our option or our variation at the same time. And we were able to capture all that. And now when we have an order, we say, hey, we got 5 or 15 or however many search tanks we're going to order. Here's a bill of materials. We can literally go to turn 14, order all the parts, and you're done. It's all in one sheet. It's very easy to read. Same thing with the flex kits. It's very easy to read.
Right.
You know all your parts, you know your quantities, and it's all right there. And then, like he was said, we duplicated basically that Excel spreadsheet into the Fastenal bins with the part numbers documented on those too.
Yeah. Yeah. And what's really nice is, because you documented that, when we do run out of like the little tiny pins that we get from Mauser,
at 100 of them each,
yeah,
or 100 in a bag.
but the funny thing is like, it took you a long time to figure out what pin that is, because you're like looking for part numbers on a tiny little pin or what connector it came out of, and then you find the mating pins for it. So you had to dig a long time to find those pins. And if we didn't document where we got them from, I guarantee shops do this all the time, where they find a pin that works and then they forget where they got it from, and then they don't know where to order them from again, or they have to spend the same amount of time finding the part number again. Whereas you just put the link straight into our bill of materials.
It's embedded in the bill of materials.
We just click it, and it brings it right into it. Right. So that makes it easy. Now, this is obviously the way we do order the bill of materials is like as simple as you can get. Google Sheets essentially is what it is. But like, obviously, actual manufacturers are going to use. I know AG, they make all the Subaru engines, and they make all kinds of manufactured stuff for even like the Broncos now too. They used Fishbowl, and I think they're switching to Odoo, so that's the software they use. But we're actually going to be adding assemblies into MSA as well, just because we deal with it, and I know enough people that do some manufacturing that could use assemblies. And assemblies are essentially what you're saying is like a bill of materials plus your labor, and then it's just built into. So when you sell the product on an invoice, it can show you either the completed project or the breakdown, right?
Right.
So you can, the single part, or it can be a breakdown of how to build that part. And you can use that, right? That's kind of the idea behind it.
Right. Yeah, that's exactly the idea behind it, is to try to give you at least a start before, maybe you're not a larger manufacturer that needs an Odoo or whatever,
Fishbowl,
whatever it is. Right.
Those are like ERP systems for like a whole enterprise. Like it manages everything. They're expensive and costly to set up, but
right. But even MSA, once that gets integrated, that'll be a good place to do it, as in opposed to Google Sheets or Excel or whatever, to try to document this. The point is to document it and to have it. Otherwise, you do what we did at the beginning, and it's an oil stained piece of paper that you have no idea what it is.
Or Alejandro never accounted for the labor, right? So he did all the materials, but never accounted for the labor, so he was not making any money.
And then never built in some margin in there, so he never knew how much money he was making, if any.
They just doubled. He said he doubled the price of the hardware, I think is what they said, which is clearly missing half of the part of with 20 hours of labor. That's a bulk of the assembly costs.
And that was our fatal flaw with making roll cages at the beginning. We had no idea how much it actually cost to build one of these things.
Right.
And it's like, oh yeah, that's like a good number. No, not even close.
And that gets into, that applies to engine building and transmission building and basically any performance parts at all. When it's time and materials or custom work, you need to know how long you are spending doing everything. So if you're not tracking time on that, you can't properly bill for it. So, this all kind of like ties into just tracking time and understanding your parts and materials. So a bill of materials, assemblies, all this is basically the same thing, just in different applications, right?
Right.
Okay, so let's go on to shadow boards next. What is a shadow board? Where do you normally see it used in, and kind of explain what it is?
So shadow board is basically a piece of harder foam rubber. And then typically it's cut out to be either a size of a drawer or maybe a shelf, some sort of workstation tool presentation area. but it's a piece of foam that's hard. You typically use a hot knife or some sort of cutter, like a heated cutter, and you cut out the shape of the tool. When we started doing it, we would lay out the tool, use a Sharpie or like a chalk marker or a grease pen, and you draw the shape of the tool, you cut it out to give it a depth, and then the tool nests inside of that board. And so a lot of the advantages of giving you shadow board is, first of all, you know exactly what tool goes where. And you can either label it. Some larger manufacturers, they'll actually have it labeled like this is a Phillips screwdriver. This is a 1 pound dead blow hammer. This is a 10 millimeter socket or whatever it is. It'll physically be labeled on there. This helps you keep track of what's in your box so you know where it is. You also know what's not there. To where if you're finishing your engine install and you're like, where the crap did my 14 millimeter socket go? Well, you can look around for a second. Oh, there it is. It was on top of the transmission that I forgot about. And then that tool would have walked away or it'd have been there for another 5 years. And next time you change oil, you see it, right?
Right.
We see that all the time on cars that come in. There's a socket on top of the transmission. So it helps alleviate that, not only for keeping track of your tools, but it also protects the customer for any kind of damage.
Yeah. And this is very common in aviation because they use a token system. I think if you take a tool out of your box, you put a token in place, and the planes can't leave the hangars until all the tools are accounted for. I think some of the toolboxes are even like digital, where if there's not all in there, they won't even like lock.
There's like a badge in and badge out for every single tool.
Right.
I've seen Snap-on has a feature like that where it keeps track of literally every single tool is in and out of the box.
Yeah, it's probably way beyond cost for like an automotive shop, but I guess if you're dealing with multi-million-dollar planes, that makes sense, right?
Depends on how far down the road you want to go with your 5S.
Okay, so what's a good application for shadow foam or shadow box boards in like an automotive shop?
I think, well, first of all, if you're talking about even when we just started with our flex kits or our surge tanks, you literally have a drawer. We open the drawer and there's a shadow board that has the few wrenches that you need. It has the cutter that you need or the wire stripper or whatever that you need, and it's all right there. It makes the efficiency of the operator much higher or your mechanic much higher. So a lot of what you want to do is you want to try to treat them as like a doctor or a surgeon or something. You only give them what they need and when they need it. So when they open the drawer to install the LS or install the Coyote motor, whatever it is, you open the drawer, there's every single thing that I need to install that engine. And it becomes very fast.
Yeah.
You don't have to fumble through your cabinet and to try to find the right tool. Or, oh, so-and-so borrowed that tool. I got to go track him down 3 bays down to go find my tool. If you had a shadow board, you open the door when you're at the end of the day and you're like, my tool is missing. I can go ping him right now and go get that tool because he had to borrow it for whatever reason.
Yeah.
So it just increases your efficiency. And then that really helps with it's just your labor cost.
Yeah, not having to look around for tools, and when you find stuff or when you're missing stuff, you know what you're missing, not just kind of like randomly finding stuff.
Right. Or when the Snap-on guy comes or your Mac tool guy comes, and then you're like, oh yeah, I need 2 different sockets that I lost or broke, and you open the board, your shadow board, and you're like, oh, those are missing. Oh yeah, I need to get those from the guy because he's here with his truck. Yeah. So you don't have to fumble around and remember, oh yeah, what did I need? Oh, I think I'm good. And then another week goes by, you don't have your tool.
Yeah, and so we did this. So my box is entirely from top to bottom shadow foamed for all the sockets, wrenches, hammers, screwdrivers, pliers, all that sort of stuff is shadow foamed. Mm-hmm. And then we did the same thing for the engine room. So building the engines, we got all the like the piston ring pliers. We've got the circlip injectors, all the sockets that we need. Like they're all 12-point because of course nothing can be 6-point. So
it's too easy.
Yeah. So we got all the specific tools for building out just the engine in one drawer.
Mm-hmm. And
it makes it easy. You just open that drawer and build your engine and it's all there and you shut it and you wipe the tools off and put it back. The disadvantages, and this is something that drives me wild, is when you actually do have a toolbox that's really organized and has just the stuff you need. Of course, a car comes in with like standard nuts and bolts holding the exhaust together. Right?
Always. Home Depot to the rescue.
So I don't have the tools, right? So it's adjustable wrench or a cutoff blade, right?
Mm-hmm. Right, exactly.
But yeah, so that's always, it drives me crazy when people don't use OEM hardware or hardware that is metric, really.
Mm-hmm.
I cannot stand standard hardware on a car that's all metric.
Right. It's very irritating.
Okay, so in the last section here, we really have standard work. what is standard work? What does it mean? What is kind of an application for it? And I mean, I definitely know this applies to a lot of like shops. So kind of explain what it is.
So, standard work is literally what the definition is. It's a way to document doing the same thing over and over again. So, if you're a specialty shop and you work on one particular car, it's always about doing the same thing in the same order. So it becomes something that you've minimized the amount of time that it takes. So you've maximized your efficiency for that. It also helps your quality control. So if you have standard work, the quality control gets built into your standard work. Like you put in this bolt or you put in this series of bolts, you do it in this order with this torque setting, and then as part of that process, you've built in, well, I've checked all these because that's part of my standard work. So standard work can either be documented or non-documented. We have a feature in MSA that you can go in and set your standard work. So if you have like an engine assembly, you go in and here's my base assembly, here's my checklist where I need to torque these items. I need to document these other things. Here's my ring gap. Here's my bearing clearances. Here's the torque that I use on all the connecting rods. You can build that stuff into the system, but however that works for you to standardize your work, makes your employees and your mechanics more efficient.
Right. And it also makes it so you can then hire someone and come and do it because they're not having to come in knowing how to do it. You can just say, here, follow this list. Here's how you do something, right? So that's what the standard operating procedure or SOP is for, right?
Right, exactly. So, like you said, a lot of times you have a new employee coming in or somebody that floats. Maybe you got one guy that works on Camaros all day and now you need to do something on a Mustang. Well, it's the same thing. You got your standard work in there. They can flip flop and then they can be more beneficial to your company or more flexible for your company.
Yeah. I'm guessing in a larger manufacturer, everything is SOP'd. Like every single process of every single step on an assembly line is here's exactly how to do it, what you need to do, the order you do it in, and it's documented and laid out and right in front of you. So
yeah, and a lot of manufacturers use kind of similar what we do with our checklists. So as you're creating your standard work, as the operator, your mechanic is going through and, they installed the front shackle and then they've installed the driveline or whatever it is. As they're going through it, they check off the steps that they've done. So now there's a trace not only as to who did it, but when it was done. And yes, it was complete as part of it. So that gives you a traceability for not only the operator, but to make sure, yes, on this car or on this component or this manufactured piece that I have in my shop, here's all the steps that I completed to get this done and out the door. I've even seen when I've ordered something online, there's a little check sheet that's in the box and it'll say, here's the things that were completed before they put it in the box. Here's your QA receipt of everything that's been completed. So,
because that's like a quality check thing, then the actual SOP documented and completed as a quality check.
Yes. And it's actually in the box that you receive. And you're like, yeah, I can trust this. This was assembled correctly because XYZ operator checked all these things. It doesn't have their name, this has initials or whatever, but it has a documented traceability for all of that.
Okay. Yeah, and this is important for a performance shop, both in manufacturing and for just generally working on a car, because if you're building engines, it's a very repeatable process, right? So if you're doing Coyote engines or you're doing LS engines or you're doing Subaru EJ stuff or Evo stuff, whatever it might be, you can build out the steps that you want to do it. You can do that in MSA. That's obviously how we do it. But laying that out so that way it's repeatable and anybody can come in and see exactly how you did it and how to do it every single time. And if you're documenting when they did it and who did it, if you ever do have problems, you can go back and see, and you can make adjustments to the process. So if you forget, we didn't check the oil galley plug on that block. So when they put it in the car, all the oil squirted out the back of the block. So we have literally done that before. That was like one of the first mistakes I ever building an engine. I didn't check the plug. I added that to my checklist. So the very first one is check the oil galley plugs, right?
Right. And in our case, a customer can see that. So they can actually see it on their end. They can see, here's all the specifications. Here's all the checklists that were complete. I can trust that everything was torqued properly. Everything was gapped properly. All the clearances were done like it needs to be.
Right. Okay.
So it's a blueprint of your engine.
Yeah. So, the standard operating procedure, pretty important. I think everybody at every shop should be using that, especially if they're doing just light manufacturing or even bigger manufacturing. It's pretty standard. So that's just things people can use, standard operating procedures. shadow boards. We've got your bill of materials or assemblies, how you're building stuff. So this is a good start. I know this content can get boring if you're not a manufacturer or manufacturing anything. So it's hard for people to like sit here and listen for 3 hours straight. But we do have a whole nother section to follow through with this on a later episode. So we'll get to that. We actually are going to correspond it to some new features coming out in MSA, so that way people can listen and understand what we're doing in the software, and then use the software to apply the logic or the theories of manufacturing inside of that. So, Richard, thanks for kind of letting us know how things are done at a bigger company and how we can apply it to a smaller company. It's interesting, and when people actually apply it, I think they'll have a lot to gain from it. So,
yeah, thank you. Thank you for letting me be here.
Okay. Thank you for watching Do It For a Living. You can find out more about this guest, this show, and even details about what we just talked about at our website, doitforaliving.net. Check out the Facebook page, facebook.com/doitforaliving, and tell us who you want to hear from. And if you're running a performance or racing shop, check out My Shop Assist at myshopassist.com. We build shop management software specifically for the motorsports industry. Most importantly, subscribe to the channel. Click subscribe, hit that notification bell. Do it now. Seriously, I'll wait. If you're watching on YouTube, the button's right there. If you're listening on a podcast app, hit subscribe there too. When you subscribe, you help us gain momentum and attract more high-level guests. Thank you for watching, and good luck.